Hello. We had a look at basic introduction to air traffic management. Let us now have a look at a few modern trends. Actually, they are not so modern because they are already in place for quite a few years, but still they are considered to be some of the latest developments, and also we will look at some forthcoming developments and the challenges in air traffic management. So, we will look at three specific topics here. We will look at some advances in the communication, navigation and surveillance, or CNS. We will then move on to the concept of free flight, which has been a dream for a very long time, and then we will proceed to the new areas, or we will look at the new emerging changes in the area of UTM and UAM. Urban air mobility and the urban traffic management. So, some advances in CNS is what we will take up first. The first thing that comes to my mind is the Aeronautical Telecommunication Network, or ATN. This is a global internet architecture for aviation data. Okay. Now, it enables interoperation of ground to ground, air to ground and avionic data subnetworks. But the beauty is that ATN uses common interfaces and protocols based on international standards, and therefore it is globally applicable. Now, there are four enabling elements of ATN which make it so powerful and so easy to operate. The first of them is that it allows transfer of data to an aircraft without the sender knowing the location of the aircraft. So, you do not need to really track an aircraft. If you have a dedicated identifier for an aircraft, through ATN you can just transmit data to that aircraft directly. Then it uses multiple air to ground links simultaneously, and therefore multiple messages can be sent at the same time. Thirdly, it accounts for low bandwidth air to ground data links available today and also in the near future. And it can also be upgraded when the better communication systems appear. Okay. And the most important part is that it is completely standardized, and therefore the air traffic services worldwide can use the ATN without any issue about interoperability. So, ATN becomes the backbone of communication today. Now, using ACARS. ACARS, ACARS is from the basic premise that even in mobile phones we always say that if you want to communicate with somebody and if you want to have a record of that communication in the future, then texting is better than calling. Okay. Therefore, because in texting there is a clarity, people can exactly read what is want to be communicated. During calling there can be errors in understanding and appreciation. So, therefore, ACARS stands for Aircraft Communications Addressing and Reporting System, which is a text based communication system between the ground stations, that is GS, and the pilots. Now, the communication in ACARS happens through what is called as VDL or VHF data link, or HFDL or the high frequency data link, or using the satellite communication using the satellite installed constellations of Inmarsat or IRIDIUM, which are already there in the space. So, we will look at the VDL and HFDL in slightly more details. The first we look at the VDL. Now, VDL is a system for digital communication between the aircraft and the ground station, particularly within the ATN. Now, it uses digital radios to transmit data over VHF frequencies as against the analog methods used earlier. So, therefore, it has much higher capacity compared to the older VHF analog data link services. Also, VDL has been developed in accordance with the ICAO standards, and hence it ensures interoperability with the aviation industry. Remember that aviation is a global trade, and therefore interoperability and validity over the entire globe is very important for such critical systems. Otherwise, there will be problems in harmonization. There are two modes of VDL, mode 1 and mode 2. Both of them, they use varying data rates and features for air to ground data exchange. So that much for VDL. Now we look at HFDL or high frequency data link. HFDL, the good feature is it has global coverage because it allows you to get cost effective alternative to SATCOM for long haul and transoceanic flights. SATCOM is good, but SATCOM is expensive because it is operated by the services provided by private satellite service providers. Okay. Now there are networks of ground stations all around the world, therefore they provide nearly complete global coverage under the HFDL. So that is the advantage of HFDL. Now in HFDL, it is automatic and adaptive. Unlike the HF voice communication which requires manual tuning, HFDL radio automatically scans and selects the best frequency and data rate applicable for a particular communication requirement. So it does not require the pilot or the ground controller to really worry about the manual tuning. It is much more robust than voice communications because it is digital, because it is adaptive technology, and it has got many algorithms for error detection and for correction of any errors. First of all, it is more resilient to the atmospheric and ionospheric disturbances, which are the real problem in HF that lead to a lot of scatter, and it is very difficult actually to understand the HF communications. HFDL can be used for a variety of data messages such as AOC, Aeronautical Official Communication, CPDLC, Controller Pilot Data Link Communication, ADS, Automatic Dependent Surveillance, and many others. So we will look at a few of them in the next few slides. The types of messages in ACARS, they vary. So there can be messages related to air traffic control such as the oceanic or pre-departure clearances, which could be communicated without necessarily talking to the pilots. Then you have the Aeronautical Operational Control or AOC, about which I mentioned. There are lots of data that are required by the airline, such as the load sheet, any weather updates, the flight plan, updating any dispatch data or any delays, automatic reporting of OOI data flight phases. So we will have a look at what is meant by OOI flight phases. So OOI stands for out, off, on and in. Okay. Out means off block times when the aircraft leaves the gate, that is when the aircraft goes out. That is when the door is closed or the parking brake is released. That is when one signal can get communicated. Off is the time of takeoff, when there is a weight on wheel sensor. So that sensor, when it detects that there is no weight on the wheel now, it sends a signal which gets recorded that at this time the aircraft took off. Then there is a on, when the wheel determines that the aircraft is now touching on the ground. That is the landing time, that is also recorded. And in is the time of arrival at the gate, when the parking brake is set and the engine is shut down. At that time also a signal is transmitted. So in all these four phases, one can use the ACARS for recording the slots. Then you can get data regarding the engine health, regarding any information about the gate at the airport. All of these are available without any intervention between the ATC and the pilot through the Aeronautical Operational Control messages in ACARS. Then you have Airline Administrative Control, AAC. Here information regarding the passenger, how many seats are available, and all other messages regarding the administrative activities of the airline, those messages can also be communicated using ACARS. Let's have a look at an example of how ACARS has helped. This happened in the recent times. All of you will know that there was an incident which shook the whole global aviation community when Malaysian Airlines flight 370 vanished without a trace. And it was very difficult to trace the aircraft because we had no idea where it went, and that was in the oceanic airspace in the Australian Ocean, and there was absolutely no information available. So now there is something called as a Satellite Data Unit or SDU. It uses the ACARS protocol, and this SDU is installed in most modern aircraft. In this particular aircraft, after an hour of the plane vanishing from the secondary surveillance radar, the SDU got turned on, and the SDU communicated a signal to the Inmarsat satellites on contact, but it got no response from the pilots. Okay. So, that particular instance, an automatic ping message was answered by the SDU. Okay. So, there was an automatic ping message and the SDU answered that. With this particular information, we were able to locate the approximate area where the aircraft was, but this was not the reason why the system was installed in the first place. Okay. But it helped. Okay. So, this particular phenomena or this particular incident, it prompted the theory of complete power failure and rebooting in the aircraft. And then we are all aware how after a lot of time the debris was recovered. Okay. Now, there are many improvements in ACARS also. As ACARS becomes popular, flights are generating more and more ACARS data, and this data is leading to frequency band overloading, because all of the communication takes place in the VHF, HF and the narrow band in SATCOM. So, there is a congestion now, the bands are overloading. So, therefore, the solution is to have ACARS over IP or internet to release some or to give relief to the frequency band overloading. So, what we do now is you can use publicly available broadband to broadcast non-safety critical messages which may not have any safety implications or legal implications, but only information related messages. The safety critical messages, they are still going to use VHF and SATCOM, and for example dispatch critical messages or the messages between the aircraft and the ATS services. So, the aircraft interface device or AID is required for these facilities. The new aircraft already have it, and in the old aircraft it can be retrofitted. Now, if you really want to protect the information, then you can use a VPN. Okay. VPN can be used for protecting the information. Now, after looking at some new aspects in communication, let us look at now surveillance. Now, surveillance is now possible in a much better way using the automatic dependent surveillance, and there are many modes of that. One of them is the mode B. So, ADS-B, which is very popular now, stands for automatic. That means the information is broadcast automatically without any pilot or external input. D stands for dependent. The information accuracy is dependent on the sensors of the aircraft. If the sensors are working properly, then the information is correct. If the sensors have an error, then of course the information could be wrong. Then there is surveillance. Info about the accurate position of the aircraft is broadcast, and this happens automatically. Now, when you say broadcast, it means the information is continuously sent and can be received by any station, and that is the beauty. Anyone with the with the appropriate instrumentation can receive this information. So, this is used a lot. So, as I said, anyone can receive the ADS-B info and track any flight. This is what is used by websites like Flight Radar or flightinfo.com, etc., to tell you where the aircraft is and to track the exact location of the aircraft. So, that is ADS-B. You also have ADS-C, which is automatic dependent surveillance, but now it is not broadcast, it is only contract. When you say contract, it means the info is available on contract to the ground stations, but not broadcast to everyone. Now, ADS-B position updates frequently, but ADS-C is updated once in 10 minutes. ADS-B definitely provides a better surveillance picture, okay, but ADS-C is more useful for remote areas and for the oceanic navigation spaces. The reason is that ADS-B has limited range since it uses the airborne transponder, whereas ADS-C, it uses SATCOM. So, therefore, it has got a much wider range. You also have space based ADS-B now. So, here this is the latest development, and there is a company called as Aeron LLC. They have provided this facility. Because the Iridium satellite network covers the entire planet, we can use it for space based ADS broadcast, ADS-B. This particular system was brought into place after the MH370 incident, because there was a need for much better and more detailed oceanic coverage, which was not available during that time. This particular scheme offers coverage in oceanic areas, and with that you can reduce the separation and allow larger throughput. For example, in the North Atlantic tracks in 2019-20, a space-based ADS-B was implemented. This allowed us to reduce the longitudinal separation from 74 kilometers prevalent at that time to 26 kilometers, and also we could reduce the lateral separation from 43 kilometers prevalent at that time to 35 kilometers. This is possible because now we have more specific and confirmed information regarding the location of the aircraft, more reliable information, and therefore you can have a larger throughput of traffic because now the separation is reduced. And now more and more countries are opting for space-based ADS-B because of its advantages. Here is an image from Aeron Corporation which shows this is how the surveillance happens correctly. It is limited to line of sight, or this is what it used to be earlier before this system was introduced. When we introduced this system, you can notice that satellites in the space are able to track the aircraft much farther distances, and also in remote areas. There are some ground facilities which augment the communication. So, apart from the line of sight surveillance which is anyway available, it gets augmented with the satellites. Let us look at some further advances in CNS. Most systems are being upgraded because of the increase in the traffic globally. For example, the TCAS has been updated to ACAS-X, which allows us for reduced separation and more uses. Then navigation models to follow the ADS-B data to improve the accuracy with respect to the other aircraft, because now ADS-B data is available which is much more accurate. Then newer ATS protocols and systems are coming in place. For example, in US we are looking at the next gen ATM system. In European Union we are looking at the SESAR implementation. But one thing I must note is that the free flight plans are slow in implementation, although they were expected to come much faster, but they are a little bit less. So, the data driven research is a key for free flight and for the next gen and SESAR CNS systems. Now, the question is why we require data driven research, and we will see an example of that. Data driven research allows physics based approach rather than just a projection. This actually allows us to represent the complex system in a simple manner, and it is based on the observational data from measuring a system behavior rather than just prediction. The data driven models can take uncertainties into account. That is the best part of the data driven systems, looking at the changes in the weather conditions, looking at the dynamics of the current traffic flow. These can be incorporated when you have data driven research. Here is an example of predicted versus actual trajectories of flights from Kuala Lumpur airport to Singapore Changi airport. These are two airports which are quite nearby. So, you can notice the red line shows the trajectories which are predicted, and all other lines indicate the actual trajectories which have been flown by the aircraft. So, you can see that it pretty much captures the essence of what route an aircraft will typically take. There are many research avenues available in CNS ATM. Data driven approach is a need rather than an assistance. It is now required because of the large volumes of data which are getting generated. Then the novel techniques to help in ground en route and terminal area ATC operations are slowly coming into bear. The flight delay and trajectory prediction is a huge requirement of modern airlines, and by doing more data driven research we can get this information more accurately. If you can incorporate real time ACD data, then we can also use it for designing the aircraft in a better way for the future. And the effect of automation on ATCOs and cyber security, these are two aspects which require further more research and studies, right. Now, there are limitations in data driven, okay. You need data set shift, there can be poor modeling of physics which can lead to erroneous results. Let us have a look at the free flight which has been a dream for a very long time. What is free flight, or FF for short? Free flight aims to remove the air traffic controller from the picture and allow operations of aircraft to take place safely and expeditiously without the presence of a human on the ground automatically. It's a dream. It's a dream, and we don't know how long it will take to actually become a reality, but it has been there for a very long time. So the idea of free flight is to shift the decision making from the air traffic controller to the cockpit, okay, and using separation management and the conflict detection and resolution, which is automated through instruments. Why do we need free flight? What is wrong with the present system? Okay. The ATCOs are today responsible for separation between aircraft, especially during the highly controlled airspace A, B, C, D, etc. Because Africa and Asia have huge areas which do not have adequate radar coverage. The workload management is becoming a problem in high density traffic situation, and the oceanic navigation follows models which are like railway between the waypoints. Okay. So these are the reasons why the ATCOs proactively provide separation between aircraft. Now, the main consideration of free flight is to significantly reduce the separation minima to allow more and more flights to take place. It is possible only through improved conflict prediction, detection and resolution. Very difficult, easy to say, but very difficult to do it manually. Now, we want to also avoid micromanagement of the aircraft by the ATCOs. Today, at every point in the transit, the ATCO approval and permissions are needed to leave the gate, to reach the runway, to start the takeoff, to reach the airways, reporting points, etc. All this is going to go if we are able to establish safe and secure free flight protocols. For example, if you look at these two places, a hostel and a destination in IIT Bombay, there is no straight path. There are multiple paths between these 2 points. If you have free flight, you should be able to go directly from 5 to IDC without the need for going through these particular routes. So, the airways that you see up in the air, they are not the optimal path between 2 points, but they are important for traffic management because on the airways we have various devices, we have various navigational equipment which help us to, it could be NDB, it could be VOR, it could be other devices which allow us to proactively locate and get the information regarding the aircraft. Free flight ensures point-to-point navigation with self-separation. This improves the capacity and reduces the congestion by a large amount. Now, another important issue is that there could be a scenario of complete power failure at the air traffic control center. This is a major risk, and till the backup is restored, okay, there is some time needed. So, for that the ATC, they print flight progress strips every few minutes which are looking like this. Okay. Now, these flight strips, they contain aircraft ID, they contain the type of the aircraft, they indicate the flight level at which the aircraft is operating, destination, departure, navigation times, etc. So, these are recorded. Now, physical copies are still in use for tackling risk of power failure, because if there is communication failure or power failure, then these are the only things available with the ATCOs for keeping a track of the situation. So, free flight removes this risk, but then there could be a telecom failure risk increase, and if that happens, because of if you have free flight and if you have telecom failure, then it is a much bigger hassle. Another issue is that the air traffic controllers are prone to strikes, they are prone to stop work. For example, this happened in July during the peak season in Europe, there was a strike. Then similarly, there were many other examples. I am just taking some newspaper reports. So, you can see there are so many examples. Then there are shortages of air traffic controllers. Here is a collection of some reports related to India. Okay, they date back to 2016, 18, 23. So there are many such instances. So therefore, there is a ATC crisis today. Okay, this is the latest driver for the free flight. Number of ATCOs which are available to man the traffic is always insufficient, and you cannot overload them because they are working on a cognitively demanding task. So therefore, they work with staggered shifts. They take frequent rests between 2 hourly duties, and it's a very delicate matter because it's a safety issue. So there are repeated strikes which happen, and therefore it can lead to problems. The government and the civil aviation authorities, they know it all too well. Okay. But the thing is that it's not very easy. It's not very easy. Simply by doubling or tripling the number of air traffic controllers, you cannot really increase the throughput. There is a limit to it. Okay. So therefore, we need to be very careful when we suggest that only staffing is a problem, so increase the staff. That helps to some extent, but not. These are trained people. They are licensed. They have their own requirements. They have their own rest periods. So it's not very easy. Now, the thing is, the reality of life is that air traffic is bound to increase year on year, which directly means that the ATCO workload will also going to increase by manifold. Okay. So just to look at in India in the last decade, 12% domestic and around 6.5% international traffic has been increased. Okay. If you look at it for the last 10 years. So in India, for example, in 2009 to 10, you can look at these numbers. The numbers are hovering around 50 million passengers or so. It has gone now to 141 million passengers in 2019-20, and it is further increased in the future. So the key purpose of ATM is to ensure and enhance safety in operations, but there are ATCOs who are also humans, and sometimes their actions are also leading to some accidents. There is a general feeling that around 6 to 10% of the accidents could be because of the ATCOs. Now, can the free flight reduce this number? For that, we need to look at the history to find out. So let us take an example from history. First example is the disaster that took place over Charkhi Dadri in New Delhi in 1996. This was the world's largest mid-air collision when two aircraft collided mid-air. There was one aircraft from Kazakhstan. Their pilots had some communication issues. They descended from flight level 150 to 140 slowly. They knew of an incoming plane at that altitude. Okay. But by the time they realized that they are at flight level 140 and began to climb, it was too late, and they collided with a Saudi Arabian flight 763. There is a documentary called as Head On Air Crash, which came in 2006, 10 years later, which I encourage you to search and have a look at. Now, what is the solution to this problem? Technology. So, India mandated that all aircraft which were to operate within its sovereign airspace should be TCAS enabled from the next year on, or 31st December of that year. This was one of the first nations in the world to do it. And for this, we need to really appreciate the stand taken by the then DGCA, Shri H.S. Khola. He took a strong stand that we will not permit any aircraft to operate. He gave a reasonable time for people, for the airlines to install this expensive TCAS system on the aircraft, but they did not want, we don't want to have a repeat of this incident in Indian airspace, so it became mandatory. Many airlines protested, many airlines wanted more time, but he took a stand, and rest is history. Also, the airways near the Indira Gandhi International Airport, they were also modified so that departures and arrivals are not on the same route. Okay. This was happening at that time. At that time, it was the same route for arriving and departure. A similar change has also been done in Mumbai Airport. Now, at Mumbai Airport, the arrival and departure routes are not the same, and also this brought into play the secondary surveillance radar, which gives you not only the information regarding the aircraft, but also its altitude. Next example is in 2002 there was a mid-air collision in Überlingen in Germany, right. TCAS told one aircraft to climb and other aircraft to descend. Okay. TCAS is the instrument on board, but the ATC gave opposite orders. Now one aircraft followed the ATC instructions, the other followed the TCAS instructions. Unfortunately, coming back to the same altitude again, and the solution to this problem is that now it is mandated that the pilots are supposed to ignore the ATC commands in case of any emergency alert from TCAS. So, this is the only place or only incident or rather only occasion when the pilots are mandated to disobey or disregard the recommendations by the ATC, and that is when TCAS gives an alert. Now, it is a trivia that there was a man who lost his family in this crash. He located actually the air traffic controller who gave these instructions and actually murdered him. There is a film called Aftermath in 2017 which is based on this incident. Now, what is the outcome of popular ATC based crashes? The outcome is rely more on technology. So, frequent flight seems to be viable to reduce ATC induced crashes provided free flight itself is secure. Then there are also many accidents which happen because of pilot error. Okay. An estimate shows that around 60% of the crashes happen because of the pilot, right. Now, the free flight will increase the workload on the flight crew because now they are responsible for separation. But how crucial is the pilot burnout? Let us understand by looking at history once again. There is an example of a ghost plane, the Helios Airways flight 522. In this flight, the cabin pressurization was left at manual by pilots during the pre-departure checks. Actually, what happened is that there was a pressurization problem in the previous flights. So, the flight engineers were testing the pressurization system. To test the system, they actually put it to manual and they were doing some checks. Next day, when the aircraft, now they are supposed to bring it back to auto, but they forgot. Okay. And the pilots are supposed to check that the system is not on manual but auto, but they also, it is there in the checklist, but they did not bother. So, the pressurization system was left to manual. Now, what happened is that the oxygen masks are carrying only about 12 minutes of oxygen, right. So, the cabin crew failed to comply with the depressurization rules and the checklist. So, what happened is the aircraft took off and after some time everybody on board was completely fainted. But the aircraft is an autopilot, so it kept on flying for a long time till the fuel ran out and then it crashed. So, there is a film called as Flight 7500 released in 2014 which is loosely based on this incident. Then let us look at two more incidents because of pilot error. The Eastern Airlines Flight 401 1972, there were warnings in the cockpit, but the crew were fixated on the faulty landing gear. They could not recognize that because of that they are losing the altitude and it became so low. Now, what has happened is they had altered the autopilot settings by mistake and they were too much focused on looking at the faulty landing gear. So, the crash of Flight 401 is a movie which is based on this particular incident. Then there is a flight in 2015 called Trans-Asia Airways Flight 235. Here what happened is the airline, the aircraft suffered failure in one of the engines. While detecting the loss and while taking corrective action, by mistake the crew switched off the good engine instead of the bad engine. So, one engine is not working, the one which is working, by mistake they switched off that engine and there was a crash. This particular accident is recorded in Mayday TV series called as Caught on Tape, episode 7 season 17. You will be able to get an idea about this incident. So, pilot error, pilot burnout is a very key issue because the pilot has to stay alert for most phases during the flight, okay, and the airline policies are not very supportive in this case. In some cases, the self ethic of the pilots is very important. There have been many instances of aircraft crashes being caused due to the bravado of the pilot or the macho approach of the pilot. Every cockpit now has 2 people on board, but the co-pilot generally is a person with much lower seniority compared to the captain, and there is a gap in the authority between the two. There can be communication constraints. So, because of that, sometimes even though the co-pilot realizes that there is a mistake happening, they are either not able to muster the courage to inform the pilot, or sometimes they inform but they are very feeble, they are not authoritative, and the pilot overrules. In some cases, even though there is a distinct information by the co-pilot, the pilot simply, the chief pilot or the pilot in command simply ignores it. And I do not want to name any incident, but there are instances we all know of crashes being caused because of such kind of a bravados. So, the free flight technology will also aim to reduce the pilot workload as well. So, many things will happen automatically, and therefore, the workload will reduce. So, the backbone of free flight is human factors plus technical aspects. It is not just technical aspects, it is a mixture of technical aspects and the human factors. Let us have a look at the focus of the free flight technology. The first priority of free flight technology is maintaining self-separation. That is their first priority. The second priority will be conflict detection and resolution, which is the primary reason why we avoid, why we provide separation. And then we also, when these two are taken care, it will also look at the optimal paths without using the air routes. It will provide takeoff and landing support. That means during these two critical phases of flight, the free flight will also provide assistance to the pilot. It will reduce the pilot workload and also prevent the pilot burnout. There is a system called as the Airborne Separation Assurance System, or ASAS. ASAS actually predicts possible conflicts because it looks ahead in the time frame and points out the possible areas of conflict. It will make use of surveillance data from ADS-B. So, therefore, it is based on the actual tracking of the aircraft. It will have quick and non-complex for pilots to understand, otherwise it is not going to help, it is going to be a bigger confusion. Okay. So, this is a challenge which has to be taken care. Then there is something called as collision prediction by trajectory prediction. Okay. The prediction of trajectory of self and others is a very important aspect of free flight. Okay. So, there are 4 steps here. One step is no intent approach, which means we only have the position and you extrapolate the position on time by looking at the velocity. Second will be we can infer the information from the autopilot, and that can give you an idea. The third could be you identify the next trajectory point where the trajectory will change, and fourth is know about the complete flight plan as per the FMS. So, this is a very important and relevant way of predicting the trajectory and therefore also predicting the areas of conflict and preventing collision. What is meant by no intent approach? No intent means the least complex and it is pilot friendly. Okay. Here the look ahead zone is a circle with the center at the aircraft and some r distance that it can cover in t minutes. So, you just look ahead in t minutes at the current speed, where will you be and is there any obstacle there. The system will look for any conflict detection within the aircraft in the look ahead zone. Okay. Now, but what if the pilot takes an unprecedented turn? It could happen because of various reasons. It could be because they want to avoid some weather. Okay. So, now just think about it. Imagine you are in a movie theater, right? Now, you can ask the pilot to check the intent before turn, but that is very cumbersome. That is very cumbersome. So, then you have predictive ASAS or PASAS. In predictive ASAS, you calculate the speed vector changes horizontal and vertical for conflict detection. So, here it is, then you look at maneuvers with possible CD to look ahead time forbidden. So, in the look ahead time that you are marking, if you are going to identify some maneuvers which can potentially lead to a conflict, those maneuvers are forbidden when you look at predictive ASAS. So, no aircraft will do a risky maneuver, therefore, it will be safe. Now, what are the free flight fundamentals? Conflict resolution has to be more advanced than the TCAS, because TCAS is the last resort. TCAS is make or break, it is that if TCAS doesn't work, then there is going to be a disaster. The TCAS, it gives you a change altitude, or rarely it gives you a change in the heading. Generally, the TCAS asks you to change, descend or climb. Okay, they rarely give a heading change. Now, ASAS is to find more optimal way for conflict resolution. TCAS does it by altitude and sometimes heading. ASAS will give you more optimal ways. There are many theories in development, and it will take some time for it to become a reality. Now, there is something called as CDTI, or Cockpit Display of Traffic Information. This has to be user friendly. This has to be, remember, already the pilots have tremendous workload because there are so many instruments in the cockpit, there are so many displays they have to monitor. You bring one more display, and if it is not user friendly, not easy to read, it is going to create much more confusion and workload for the pilot. So, these systems have to be easily commandable, and they can be overridden by the humans. That is needed, because in the crux situation, it is the human being on board who can take decisions to avoid incidents. So, simulations, hardware in the loop simulations are being conducted right now to check the CDTI and how it can function. Thank you for your attention.